Scalability and Performance. One of the biggest hidden benefits of using Iis 6 is in its ability to scale. In this video, we'll discuss the features and settings you should use to assist Iis 6 in its ability to scale and perform well for your organization. One of the great new features of Iis 6 is the worker process isolation mode. Using this mode, Iis 6 runs web applications isolated from each other by allowing applications to run in separate application pools. And because worker processes operate separately from each other, if a worker process fails, the web service simply shuts it down and starts another web process. And because web processes operate separately from each other, if a worker process fails, the web service simply shuts it down and starts another worker process to continue processing. And because worker processes operate separately from each other, if a worker process fails, the web service simply shuts it down and starts another worker process to continue processing requests that may be queued, or waits until another request comes in before starting another process. So the end result is a more robust and stable web server. For a more detailed One of the other great things about Iis 6 is that it doesn't allocate all of the system resources it might need at startup. Instead, it waits until these things are actually needed before firing them up. An example of this would be when an application pool only starts processes the first time a request for a URL is received by the application pool. Iis 6 also supports web gardens. A web garden is simply multiple worker processes that service an application pool. So if a worker process is busy servicing a request and another request comes in, then these worker processes in the web garden can accept and process those requests for the application pool. Centralized logging is yet another benefit of Iis 6. Imagine you have a web hosting company that hosts 1,000 websites on a single Iis server. By using centralized logging, all of these websites can write to a centralized log file rather than each of them writing to 1,000 different ones. Using centralized logging can save a lot of CPU and memory, as you don't need to open and write to 1,000 files at once. Now, Iis also supports bandwidth throttling, and this is great if you're like me and you don't have an unlimited amount of bandwidth to play with. Now here we can force Iis to only use a certain amount of bandwidth so that our other services such as email and internet browsing also have their fair share of bandwidth. Now, aside from these great features, Iis 6 can also utilize multiple CPUs and supports processor affinity, whereby you can configure application pools to launch worker processes on specific CPUs. And with support for up to 64 GB of RAM, it's no wonder that Iis 6 scales much better and performs better than previous versions of Iis 6. And with support for up to 64 GB of RAM, it's no wonder that Iis 6 scales better and performs better than previous versions of Iis. Now, whilst this isn't a specific Iis configuration option, when Iis 6 is run on a Windows 2003 server, it can take advantage of network load balancing. And network load balancing enables you to take two identical web servers and have them both respond to requests one at a time. On busy web servers, this will certainly improve the response of your websites. Okay, the next thing we're going to look at here is the Iis queues, and there are 4 queues that we need to concern ourselves with. Now, the first type of queue is the Tcp Ipq queue. At the Tcp IP layer, high priority threads respond to client requests by checking to see that the server is either accepting or it's not accepting and processing client requests. If the server is up and accepting requests, these threads maintain the customer connection and pass the requests to http.sys. Now, if you're having problems on a busy web server where users simply cannot connect to your site, you might need to adjust the Tcp IP queue. So to monitor the Tcp IP queue, we'll use our good friend the Performance Monitor. So let's fire it up first by clicking on Start, Administrative Tools, and then coming down here and launching the Performance MMC. Now you're probably all very familiar with this tool, so we'll get straight into it and we'll expand our performance logs and alerts. We'll right click on counter logs and we'll select new log settings. Now we'll need to give our new log a name, and I'm just going to call this one Tcp Ipq and click on OK. Now this brings up the properties for our new performance log. At the top on the General tab, you'll see the name of the log file and the location where it's going to be stored. So the first thing we're going to have to do is add a counter. So we'll click on Add Counters. And at the top here, we have the option to use counters that are available on the local machine or available from a specific machine. Now our specific machine does default to our local machine anyway, but if we do want to use a different machine, we can enter in the name of the machine here. So under our performance object drop-down box, you'll need to select either TCP version 4 or TCP version 6, depending on whether you're using IP version 4 or IPv6. Now in 99.9% of cases right now, I'd wager that it'll be TCP version 4, so we'll select that option. Alright, so now we need to select one or more counters from our list. Now primarily we're interested in connection failures and connection resets, but you could certainly monitor any of these other counters as well. So what we'll do is we'll come up to the top here and we'll select connection failures, and then we'll come down here and click on the add button. And then we'll also select connection resets and also click add. And now we'll click close, and we can see that our counters have been added. Okay, we can now see the sampling interval has been set for every 15 seconds, and that's fine for my purposes because we don't have anyone connected to our Iis server, but on a busy production server, you might want to change this value. So we'll just click on OK. Now we will get a message telling us that our directory we're going to save our performance logs in doesn't exist, and that's because this is our first log that we've actually configured on this server. So we'll just say yes to create our performance logs directory. Okay, now if we click on counter logs, we can see that our log up here is running, as indicated by the green disk platter icon next to here in the right hand side of our MMC. Now once you've captured enough data to produce a good sample of what your server's up to, it's time to analyze the data. So we'll right click on our performance counter, if I get the right one there, and then we'll choose stop to stop the counter from collecting more data. Okay, once it's stopped, it was changed to red, indicating that data collection has ceased. So what we'll now do is select System Monitor in the left hand side, and then on the toolbar, we'll select the grey little database looking icon here to view our log data. Now this opens up a new window, the System Monitor Properties. So what we'll need to do is provide the name of our log file. So we'll choose our data source as a log file, and then we'll choose Add. Now here we can see it does default to our performance logs directory, and we have our TCP IP log here, so we'll select that and choose OK. And then OK again. Now we'll come over here and we'll select the Data tab, and we have to add in the performance counters that we added to our original performance log when we created it. Now we already have memory, disk and CPU listed here, so we'll go and click Add, and from the drop down list we see we have our connection failures and connection resets. So we'll select the first one, connection failures, and choose Add, and then we'll select our connection reset and choose Add again, and then we'll choose Close. Now we can see all 5 of these performance. And now we can see them listed on here. And now we can see these 2 counters listed here, so we'll click on OK. Right, now we can see that our graph changes to display the data that we've just collected. Now obviously this really isn't going to tell us too much about the connections on our Iis server because there are none. But in your environment, running counters like this when your Iis server is busiest, this will give you some really good data and possible justification in asking the boss for that new whiz-bang server you're after, or perhaps just make you realize that network load balancing isn't just for the big boys. Now, if we come up here and click on the View Report icon, we can get a text report on what the status of our server was across the monitored period. And as you can see, our connection failures and resets were rather small, 0 in the case of failures, 6 in the case of resets, and that's exactly what you'd want to see in a perfect world. And as you can see, our connection failures and connection resets. And down here, you'll be able to see the results of our connection failures and resets. And this will give you a good idea of what the TCP Ipq is like on your Iis server. Okay, the next queue type we want to look at is the Kernel Request Queue. Now, when the TCP Ipq passes a request to http.sys, http.sys will do one of two things. It'll retrieve the content from the http sys cache if it exists, but if what the user has requested doesn't exist in the cache, it will put the request into a kernel request queue, and then the content will be requested retrieved on a first in, first out basis. Now, http.sys is pretty smart, so before it even pops the request into the kernel's queue, it checks to see how busy the kernel's queue is. If the kernel's queue is full, then http.sys drops the request, and then the user is presented with a 503 service unavailable error. So in our Iis MMC, we can configure the kernel queue by right-clicking on Application Pools and selecting Properties. And then we'll select the Performance tab. Now here we can see the request queue limit, which is enabled by default and has a maximum of 4,000 requests that can exist in the queue at any time. Now you can set this value higher or lower as you see fit. If you find on a really busy server that you're getting a lot of 503 errors, then set this value higher to see if that solves the problem. Now, one thing that's certainly possible here, but not recommended, is removing all values from this box or simply unchecking the request queue limit box. Now, on the surface, it might seem like because either of these situations will prevent Iis from enforcing any kernel because either of these situations will prevent Iis from enforcing any kernel request queue limit. Now, on the surface, that might sound like a good thing, but it also means that Iis will keep queuing items up until the server potentially runs out of memory and falls in a heap. Probably not the Now, on the surface, that might sound like a good thing, but it also means that Iis will keep queuing items up until the server can potentially run out of memory and it'll fall into a heap. That's probably not the desired result. So be careful that you leave this setting enabled and play around with the value until you don't see any more 503 errors. Okay, the next queue type is the Asp Request Queue, and as obvious as this sounds, it's a queue for requests for Asp pages. Now, what happens with requests for Asp pages is the worker process grabs the request from the kernel request queue and then passes it to the Internet Server API handler or the ISAPI handler, which in turn passes it to the Asp DLL. Now, if a thread is available to process the request, then the request is processed. If the thread's not available, then it's queued in the Asp Request Queue. Now, an Asp Request Queue by default will hold 3,000 events. If this is full and a new request comes in, the request will be dropped and Iis will send an error 500 to the client, indicating that the server is too busy. Now, as with our kernel request queue we looked at a moment ago, we can change the default configuration of 3000 requests in the Asp request queue. However, we'll do this here by opening up the metabase.xml file and changing the Asp request queue max value. Now, this metabase file, of course, can be found in your system directory /system32/inetserv, and we'll open this file up with Notepad. So I'll right click and select Open With, and of course use Notepad. And I'll just expand this to make it a little bit easier to see here. Okay, so I'm going to hit Control F and I'm going to type in here Asp Req and hit Find Next. And down here we can see the Asp request queue max value. And of course, as we said before, it's set to 2000. Now you can certainly change this here if you wish. Now just above this we can see the Asp processor thread max is set to 25. But as with our queue max, you can also change this value to something a little more appropriate for your circumstances. Now typically you would adjust this thread value if you experience a lot of issues with other processes that delay the processing of your Asp request. So consider an example where your Asp page has to go and fetch data from a database which exists on a different server. Now you might be receiving several Asp requests a second, yet to retrieve the data from the database takes 5 seconds. Then Asp requests will be blocked. Now in situations like this, especially if your CPU utilization on your web server is a little low, say below 50%, you might want to increase the thread value to something a little higher, say within the area of 40 to 50% here. Now when you increase this value, you will expect to see a minor increase in CPU utilization, but requests from your Asp request queue should cycle through faster. Now you can continue increasing the thread count to improve the queue response, but make sure that your CPU doesn't exceed 70%. Otherwise, it might be time to look at adding another server to your web farm, or perhaps finding a better way to solve the bottleneck problem, which in this example would be the database. Now finally, if you do make a change here, you will need to restart your web service on your Iis server, unless you have enabled the edit while running feature of Iis, which we've discussed in detail in the video on the Iis metabase. But I'll give you the short version here for those who haven't yet watched that video. All you need to do to enable edits to the metabase while your Iis server is still running is to go to our Iis MMC, right click on the server, select Properties, and then enable the direct metabase edit feature. Once you've done that, simply click on OK, and now that value takes effect. Now back on our metabase.xml file, there are actually 2 other values here that will affect your Asp request. And they are the Aspq timeout property, which specifies how long in seconds that an Asp script request is allowed to wait in the Asp request queue. Now what happens here is when requests are retrieved from the Asp request queue, they're checked to see if they've expired before being processed. Now if they've been in the queue longer than the value that's listed here, then they're rejected. And if they're rejected, the user will receive a 503 or service unavailable message. However, this doesn't apply to valid connections, as the default for valid connections is to hang on to those requests regardless of how long they've been waiting. Now the other value to consider is the app pool queue length, and we can see that one listed just over here. Now this property tells http.sys how many requests it needs to queue up for an application pool before it starts rejecting any future requests. Now if this maximum limit for the app pool queue length is exceeded, Iis will discard any additional requests and the user will receive a 503 service unavailable error. Okay, the fourth and final queue type we need to look at here is the ASP.NET Request Queue. Now the ASP.NET Request Queue actually consists of 2 queues, the global queue and the application or virtual directory queue. Now the global queue is managed by the ASP.NET_WP process that runs ASP.NET and is configured in the machine.config file. So if you open up Windows Explorer and navigate to your Windows, Microsoft.NET, Framework, followed by the version of Microsoft framework that you're running. So if you open up Windows Explorer and navigate to your Windows directory /microsoft.net/framework, followed by the version of the framework, and then into your config directory, you'll see a file here called machine.config. Now if we open this up with Notepad, and I'll just have to select this program here. So we'll choose Notepad and select OK, and I'll just expand this to make it a bit easier to see. Okay, now as before, I'm just going to hit Control F to perform a search, and we're going to search for the request queue limit. So I'll hit the Find Next button. I'll just move this out of the way to make it a little bit easier to see here. Okay, now I'm just going to hit Control F, and what we'll do is we'll perform a search for request queue limit. Now I'll just hit Find Next a couple of times here until we can find the value that we're looking for. Okay, and here it is. Now I'll just scroll down a little bit more so we can see most of what's here. Ignore all that crap. Okay, now I'm just going to hit Control F and perform a search for request queue limit. And I'll just hit Find Next 3 or 4 times here until we're down to this section where we can see the request queue limit. Now this value of 5,000 determines the total number of requests that Iis 6 will serve before a process is shut down, and we can see that defined up here. And we can see our request queue limit defined up here as well. Now our options here include setting this to a finite number, which we have in terms of 5,000, or we can set it to the word infinite, and that will give us an unlimited number of requests. Now generally speaking, you probably don't need to adjust this setting unless you happen to be running Iis 6 on a server that has more than 8 CPUs, as Iis is already configured with the best setting. Now that said, on servers with more than 8 CPUs, you might actually want to scroll down here a little bit and increase and decrease the max worker threads and the max I/O threads a little for more powerful machines if you decide to make the queues longer. Okay, now the other queue we mentioned a moment ago is the application or the virtual directory queue. So if I just select the search upwards button here and then click on Find Next a couple of times, we'll see the app request queue limit that's set to 100, and this sits under our HTTP runtime setting. Now the HTTP runtime class provides runtime services for ASP.NET applications, and it provides one queue for each virtual directory in Iis. Now unlike regular ASP, ASP.NET is likely to queue more requests. Now that's not necessarily a bad thing though, as ASP.NET can process requests faster. So whilst the default setting here of 100 application requests to be queued is fine, on fast multiprocessor machines, it's probably okay to bump this up a little if you feel It's probably okay to bump this up a little if you feel you need to, and you'll probably be more than likely to want to do this if you only have a few virtual directories. And Microsoft recommend bumping this up to anywhere between 200 to 300 in these situations. Alright, now the next thing we need to consider when looking at the scalability and performance of our Iis infrastructure are the various Iis caches. Now the first type of cache is the URI or user mode cache. The URI cache is used by the Iis admin service to cache metadata about a URL. And this metadata is information about the URL, such as what authentication is needed to retrieve the URL and its header information. Now, one thing to remember when dealing with the various Iis caches is that in the majority of cases, these caches should not need to be modified in any way. And if you happen to be monitoring the web service cache counters using the Performance MMC and you notice a lot of cache misses, then you might consider taking a look at configuring some specific cache options. So back in our Performance MMC, we'll right click on our counter logs and we'll choose new log settings. Again, we need to give our new log a name. So I'm going to call this one here Web Service Cache and then click on OK. Now we'll need to add some counters to our performance log. So we'll click on the Add Counters button. Now because we're already on our web server, we'll leave the default selection of using the counters on our local server, which is server 01. Now under our performance object, which does default to our processor, we'll need to select the drop-down box and scroll all the way down to the bottom here and choose the Web Service Cache. Now there are quite a few counters here in this list, but the actual counters that we want to really concern ourselves with here are at the bottom of this list. So if we scroll all the way down the bottom, here we see the URI objects. Now the first object we want to look at here is the Uri Cache Hits. Now Uri Cache Hits monitor the total number of successful lookups in the user mode cache since the service was last started. Now the values you can expect back from this counter really depends on the content on your web server. If the content on your server can be stored in the http.sys cache, which we'll discuss shortly, then you should expect the value of this counter to be quite low. Conversely, if http.sys cannot cache most of your content, then you'd expect the counter value of this object to be rather high. Now things that http.sys can't cache are things like query strings in the URL, or a footer on the web page, or pages that require authorization to access. In these situations, expect that your user mode cache will be hit hard. Now next, we'll click on Add here, and the next one we need to look at is Uri Cache Hits percentage, which monitors the ratio of Uri Cache Hits against the total cache requests since our service was last started. Now, like before, this depends largely on the content and whether or not http.sys can cache it. Again, if it cannot be cached by http.sys, you should expect the counter values to be rather high. Now finally here we have cache misses, and this counts the total number of times that content was requested from our user mode cache since our service was last started and couldn't be found. Now what we're looking for here is a low value to be returned. If Iis cannot locate the content in either the Iis file cache or the http.sys cache, then the value for this monitor will increase. So we're looking for low values which indicate that the Iis file cache or the http.sys response cache are doing their jobs properly and responding to requests from the cache and not from disk. Okay, the next cache we need to look at is the token cache. Now in our video on Iis authentication, we've talked about token caches which are used by Iis to cache a Windows logon authentication. In the video on authentication, Now the next cache we'll look at is the token cache. In our video on authentication, we've already talked about token caches, which are used by Iis to cache a Windows logon authentication token so users don't need to re-authenticate themselves for every single request. Now by default, a token will live for 15 minutes. Now if a user attempts to log on and a cache token doesn't exist for them, then Iis calls the lsass.exe process to go and get another token. Now whilst token caching does provide a performance boost, it is slightly more of a security risk as determined attackers could use a token in the cache to gain access to your system. So if you're particularly paranoid about this, you can turn off token caching if you want the additional security, but you need to do that through the registry. So if you watch our video on authentication, we'll show you exactly how to do that. Now the next type of cache is the file cache. The file cache does exactly what you think it's going to do. It caches files to memory. Now, if the file is larger than 256 kilobytes, then the file itself isn't cached, but a file handle is created by Iis and then passed off to the http.sys queue. The original file handle created by Iis is then closed to free up some memory. Now by default, Iis will only cache a file if it has been requested at least twice within a 10-second period. But if you want Iis to always cache files, then you'll need to set this in the registry. So if you open up regedit and expand your HKey local machine, followed by system, followed by current control set, followed by services, and we'll scroll down until we can find the inet info key, and we'll expand that. And if we select parameters, we're looking for an entry for activity period. And then we'll right click on parameters and we'll select a new dword value. Now we'll need to give this entry the name of activity period, and then we'll need to ensure that it has a data value of 0. Now having this data value of 0 will force Iis to cache every single file. Now you will need to restart Iis for this change to take effect. Now a final point I should make about the file cache is that Iis is smart enough to know when files have changed. Well, actually it's the Windows operating system that has the smarts, and it notifies Iis when a file inside a directory has been changed. Now if Iis is caching the file, it'll flush the old file from the file cache so users aren't given an old copy of the file. Now when monitoring the performance of Iis, we can again use the Windows Performance MMC to monitor our file cache. And like with our Uri Cache, the performance counters we need are part of the Web Services Cache Performance object. So we'll go and select our Performance object here. And if we scroll all the way up to the top of the list, the first counter we need to look at is current files cached. Now this counter displays the number of files whose content is in the Uri cache. Now like with other objects we've discussed, if HTTP sys cannot cache certain files, then we'd hope to see a high value reporting back here indicating that the file cache is serving lots of files from memory rather than the hard disk. Conversely, a low value here would indicate that http.sys is serving a lot of largely static content. Now what we don't want to see here is a low value when our site is largely served by scripts. Now what we don't want to see here is a low value when our site is largely being served by scripts and queries. Okay, the next counter we want to look at here is the file cache flushes, and this displays the number of times that the user mode cache has been flushed since the service was last started. Now do note that if we click on the explain button, it tells us here that this counter represents the number of times that files have been flushed from the cache, which is incorrect. This counter doesn't count individual files, only the cache itself. Now you should expect this value to be high if you change or edit files on a regular basis. Okay, the next thing we have here is cache hits. Okay, the next counter that we have here is file cache hits and file cache hits percentage. Now, file cache hits displays the number of times that a lookup inside the file cache was successful. Now, like before, if HTTP sys cannot cache files, then a high value here is good. Now, the file cache hits percentage displays the ratio of user mode or URI file cache hits against the total cache requests since our service was last started. Now, if this value is low, you might want to check out the activity period registry key we looked at earlier and set it to a higher value than the default of 10 seconds, or set it to 0 to always cache. Now, next we have file cache misses, and this displays the number of times a lookup in the cache was not successful. Now, because we want the cache to serve files, a low value here is excellent, which indicates that Iis is finding the files it needs in memory and not from the hard disk. So we'll scroll down a little bit more, and then we can see the total flushed files. Which is the number of file handles that have been removed from the URI cache since the service last started. Now, generally, unless you change files, or modify files on a regular basis, this value should be pretty low. And finally, we have the total files cached object, and this is the number. And finally, we have the total files cache counter. Now, this represents the number of files that have been added to our URI cache since the service was last started. Now, this should be very familiar to the first counter that we looked at, the current files cache counter, and again, it should be quite low. Okay, let's move on and take Okay, now let's move on and take a look at the http.sys response cache, which is also known as the Kernel Uri Cache. Back in our Performance MMC, we're looking for counters that start with the word kernel. You see, with http.sys cache, responses are served from the kernel, and this drastically improves Iis's response times because requests for content that is cached never enters Iis user mode. So the first counter we'll look at is the kernel URIs cached. Now, this displays the URI information blocks that are currently cached by the kernel. If the content on your web server is largely static, then we should expect that this value will be high. Now, likewise, with kernel URI cache hits, kernel URI cache hits percentage, and kernel URI cache hits per second, and of course, if we scroll, and also the total URIs cached, we should also expect these counters to be high with largely static content on our web server. Now, conversely, with the kernel URI cache flushes and kernel URI cache misses, we'd like to see these counters producing low values, which indicates that content is being cached and retrieved from the caches when it's needed. Now, finally, we have the Asp Caches. Now, the Asp case is used for caching templates or template files that contain Asp scripts. Now, when an Asp template is used, it's first compiled and then stored in the Asp cache for reuse. if the cache contains the template it needs, then it doesn't need to be recompiled, and this enhances the performance and scalability of Iis. Now by default, the Asp cache stores up to 500 templates, and if we fire up our metabase.xml file, and we'll just open this up here with a notepad, and we'll just expand it. Now I'll hit Control F, and if we do a search for Asp script file cache size, and we hit Find Next, we can see that the value defaults to 500. Now, once there's 500 templates cached and a new template needs to be cached, then the oldest one is written to disk whilst the new one is written to the memory cache. Now if we scroll up a little here, we can see the Asp max disk template cache files is set to 2000. So once our Asp cache in memory is full with up to 500 templates cached, these templates will then be written to disk where it can store up to 2000. Now with most of these settings, you can certainly change them if you want to. Now as with most of these settings, you can certainly edit these numbers if you want to. Now if you don't have the edit metabase while running feature of Iis enabled and you make a change, as normal, you're going to have to restart your Iis services. Now, you can also, by the way, make this same configuration change from within the Iis MMC, which is generally a safer way. So we'll go back and click on Start, Launch Administrative Tools, and then the Internet Information Services MMC, and I'll just expand this a little here. If we'll expand our server now and expand our websites, and right-click on our websites and select Properties, followed by the Home Directory tab, down the bottom here under Application Settings, we'll go and click on the Configuration button, and finally the Cache Options tab, and finally the Cache Options, and finally click on the Cache Options. And finally the Cache Options tab. Now here we have options to disable caching of Asp templates or to cache all Asp files into memory. The default, as we already know, is to cache up to 500 templates in memory and up to 200 on disk, but you can change those as you see fit. Now finally, we can see and change the path to the template cache directory here for our disk cache, and we can set the maximum number of scripts that we wish to be cached, of course, which defaults to 250. Okay, now the final thing that we're going to look at in this video is making global Iis cache changes. Now the global changes that we're going to look at must be made in the Windows registry, and you perform these changes back in the last key that we looked at, which of course is our HK local machine, system, current control set, services, inet info, and then select the parameters tab. Now these global changes must be made in the Windows registry, and you perform these changes back at the last key that we were looking at, which of course is HK local machine, system, current control set, services, inet info, followed by parameters. Now firstly, Iis by default will dynamically adjust the file size. Now by default, Iis will dynamically adjust the size of the file cache for static files every 60 seconds. Now if you want to manually adjust this so that you can allocate a certain amount of memory for the file cache, you could simply click on Parameters, select New, dword value, and then give the entry a name of mem cache size. Now, if we double click on this value, we can set a manual value of anywhere between 0 and 2,500 megabytes. Now, in most cases, performing this change is completely unnecessary, but the option is always there. Okay, well the next Now the next change that you can make is to change the time to live for objects that are stored inside the cache. So again, we'll right click and we'll select a new dword value and we'll give the entry the name of Object Cache TTL. Now if we double click on this key, if we double click on this, we can set a manual value of anywhere between 0 seconds and 4,294,967,295 seconds. Wow. Which is just the same as saying unlimited. Or we could simply type in OX followed by 8 Fs, and that will then disable it completely. Now the default value for Iis is 30 seconds. Okay, now the last key we want to look at is setting setting is to disable all static file caching. Now it's not recommended that you do this as it will slow down the performance of Iis. So unless you're doing some debugging or troubleshooting, I'd suggest that you don't make this change. But if you are a glutton for punishment, simply right click on parameters again, select new, dword, and we'll give this entry the name of disable memory cache. Now, if we double click on this, we can either set it to a manual value of 0 or 1. Now 0 will disable the cache, 1 will re-enable it. Okay, now up to this point, we've talked about the scalability and performance of Iis, but this really goes hand in hand with performance. Now up until this point, we've talked about the scalability of Iis, but this really goes in hand with the performance. So let's now go back to our performance MMC and take a look at some of the other counters that we can use to ensure that Iis performs at its peak. So we'll go and click on Start, Administrative Tools, and we'll come down here and select Performance. Now, whilst I'm talking about performance, it's important to realize that here we're interested in establishing a baseline for our Iis server. If you're more interested in what's going on right now, you can use the Task Manager or Network Monitor to accurately find out how your system is performing as a whole. If you want to establish how well your system is performing over a longer period, you'll be coming here to the Performance MMC. Now, as with any server, we're really interested in 4 core things: memory, disk, CPU, and network performance. And I'd suggest taking a look at our video on the performance monitor for Windows 2003. Now, in addition to these, in addition to memory, disk, CPU, and network, I would add to that list things like the SMTP, NNTP, www, and FTP services for your Iis server. So to monitor these key services under the Performance, Logs and Alerts, we'll right click, we'll select a new log, we'll just call this one here for the sake of the argument System and choose OK. We'll click on Add Counters. Now in the middle here under our Performance object, which defaults to Processor, we'll go and select Process, and on the left hand side here select the counter that you wish to deploy, such as %processor time, and on the right hand side we can select the process that we wish to monitor. So from here you can establish a great baseline of what your server is doing. So what's performing well and what's hogging all of the resources. Now with this valuable information, you can determine the best course of action, which might be to leave everything as it is, or perhaps move your FTP site to a different server to free up some resources for your websites, and so on. Alright, in this video, we've looked at some of the settings and features of Iis version 6 that improve the scalability of your web server over its predecessors. Iis 6 out of the box is relatively self-tuning, and for the most part you shouldn't even need to get under the hood and make any of these changes we've discussed. But when making changes like we've discussed here, always opt for using the Iis MMC if you can make the change there. Use the metabase second and the registry last, just to ensure that the change is made safely. And as always, make sure that you have a good reliable backup before committing any changes. Iis 6 is more secure, and it's faster and more scalable than ever before, and you should continue to grow and easily meet your web service needs now and into the future.